Good day, folks. This is question 5, which is the reaction rate. Let's cut the chase. This is Northwest, September 2023. Okay, let's cut the chase. Experiment 1 and 2 are conducted to investigate one of the factors that affects the rate of reaction using a reaction between magnesium carbonate and an excess hydrochloric acid. Here's the reaction. Magnesium carbonate is a base with an acid, hydrochloric acid, there's a salt water, and carbon dioxide. Now, the reaction condition used in each experiment is follow. In experiment 1, they use a 12 gram of an impure magnesium carbonate granules react with 100 cubic centimeter of hydrochloric acid at a temperature of 25 degree Celsius. At experiment 2, they use 12 gram of pure magnesium granules react with 100 cubic centimeter of hydrochloric acid at the same concentration used in experiment 1. So the only difference between experiment 1 and 2, it's the mass is the same, but this is the 12 gram of an impure. Do we understand an impure? When we talk about an impure, we talk about an impure sample which contain the part that is what is pure and impurities. So this is an impure sample, right? Now, when we talk about the pure, we're given in experiment 2 the 12 gram of this. It was the 12 gram of this in experiment 1, but now it's a 12 gram of the pure one. Remember, in terms of percentage purity, the pure part is the one that is going to react with an acid. So when an acid is poured 100 cubic centimeter of hydrochloric acid that is poured in the 12 gram impure sample, only this part will react. Now, when the 100 cubic centimeter of the same concentration poured on the 12 gram of this, only this will react. All right? Okay. Now, let's answer the question. Now, question 5.1, it says define the term rate of reaction. The rate of reaction, guys, you define it according to the exam guideline. It says the change in concentration of products or reactant per unit time. Change in concentration of product or reactant per unit time. There are other definitions, guys, but I'm not going to dwell on that. Read the exam guideline. Now, guys, we're given the graph. Now, it says the volume of carbon dioxide collected in experiment 1 recorded at equal time interval represented in the graph below. Guys, as we have seen that when the base react with an acid, there will be a salt, water, and the carbon dioxide. So this carbon dioxide is collected to investigate the rate of reaction. So in our dependent variable, we have the volume of gas and time here. Now, if you look at this graph, at 0 time, no gas is produced. As the time progresses, the rate in which the gas is produced increases, and then it slows down, and then it reaches completion there. So this graph, it's a graph of production of the carbon dioxide, right? Yeah. Now let's answer 5.2. It says give reason why the gradient of the graph is 0 between 60 and 80. Where's the time of 60? Here's 60 and 80. If you look at the gradient here, is flat. The gradient is 0. The gradient from here, it's steep, and then steep, but the steepness is not the same. But here, the gradient is flat, is 0. Okay, so the answer here, it will be the reaction has reached completion. So the reaction has reached completion. That's what you need to answer there. reaction has been reached to its completion. All right, or you say reactants are completely used up. Right? Okay, let's go to 5.2. 5.2, it says use the information in the graph to answer the following questions. Now it says what volume of gas in cubic centimeter decimeter is produced at 30. Now when you look at 30 seconds, look at 30 seconds, and the value that corresponds with it's 0.5. That's 0.5 what? Cubic decimeter. Now 5.3, it's quite an interesting question. It says calculate the mass of impurity. Right? When we talk about the impurity, guys, let's go back here. We have an impure sample. An impure sample, it contains the pure and impurity. So when we talk about the impurity, we're talking about the other part that does not react with an acid. Remember, I said when you pour an HCl here, it's the pure part that will react with an HCl. The impurity, it's not going to react. So we want this. So surely, how are we going to do it? We need to get this, and then we minus from this, we'll get this. I hope that makes sense. Okay, let's do it. Okay, so 5.3.2, guys, it says calculate the mass of impurity of magnesium carbonate. Take the molar gas volume at 25 degrees is 24. Guys, we from the graph, they said we must use the graph. This is an amount that is produced of the carbon dioxide that was collected, the entire amount that was collected. But what do you need to understand? That the entire amount that is collected of carbon dioxide, it's produced when these two reacts, right? So now in this question, we wanted the impurity out of the impure sample. But what we are told here in experiment 2, in this question, they want in experiment what? Calculate the mass of impurity of magnesium taken that. Okay. So what are we going to do now? We need to find this value here. We need to find this value here in the graph. What is this value? Right? So we have a 3 and a 3.5. And the difference between the two, it's 0.5, right? So if it's 0.5, how many lines do you have there? 1, 2, 3, 4, 5. Okay, we'll say 0.5 divided by 5, it will be 0.1. That means each and every line there represents 0.1. So it's 3.1, 3.2, 3.3, 3.4. So this line is the fourth one. So this value is 3.4. I hope you get that. So that's the volume that is produced. The volume of carbon dioxide produced, it's 3.4 cubic decimeter. So this volume, we told that we take the molar gas volume at 25 degrees as well as 24. It's more of like it's at STP. So we have to convert this volume into number of moles. While converting this volume into number of moles, we'll do the mole ratio between this and this. So this carbon dioxide, it's produced when the pure react with the hydrochloric acid. So if we have this amount that is produced, we'll get the amount that reacted of the magnesium carbonate. So let's first convert. We'll say number of moles is equal to V over Vm. But now what you need to remember, we are given the Vm here. This Vm is 24. It's not 22,4. We are given the molar gas volume. So we'll say number of moles of carbon dioxide equal to volume. It's 3.4 divide by 24. So our answer here, it will be 0 comma, what's the answer? It will be 0.14 mole, right? That's still the carbon dioxide. So what are we going to do? We'll do the mole ratio as I've mentioned before. So we'll say magnesium carbonate is to carbon dioxide. Let's look there. What is the mole ratio between the two? Is 1:1. Let me erase this. The ratio is 1:1 there, as you can see. So 1:1. So if it's 1:1, so that means it will be the same. Magnesium carbonate will be 0.14 as the carbon dioxide is 0.14. So now this simply means that the number of moles of magnesium carbonate reacted, or that is pure out of the impure sample, it's 0.14 mole. So we have to change this into number of moles. But before we change into number of moles, let's first get the molar mass of magnesium carbonate. The molar mass of magnesium carbonate is 24 for magnesium and 12 for carbon and 16 for oxygen, but there are 3 oxygen. It's going to be what? 84 grams per mole. So now what are we going to do? We're going to change the number of mole into mass. Number of moles is equal to mass over molar mass. Now the mass is the one that we want. The molar mass of magnesium carbonate is 84, and the number of moles is 0.14. So if you punch that in the calculator, you will get the amount that is the mass, which is 11.76 gram. It's still the same amount, but it's in mass now. Now, what are we going to do? We have now the mass of magnesium carbonate, which is pure, which is now 11.76, and we want the mass of magnesium carbonate, which is the impurity, right? Now we have, do we have the mass of magnesium carbonate, the impure? Let's look at the mass of this is experiment 1. We do have the mass of the impure in experiment 1. Remember this, we using experiment 1. The mass of impure is what? It's 12 gram. So what are we going to do here? Since we want the impurity, we'll say mass of magnesium carbonate impurity is equal to the mass of what? Magnesium carbonate impure. I'll show you by drawing, minus the mass of magnesium carbonate pure, which is, when we talk about pure, we're talking about this amount. Guys, basically we have an impure sample, which is 12 gram. This is an impure. Remember I said that the impure, you have the pure part and impurities. So we are looking for this guy. We are given this guy, which is 12, and we just found the 11, which is this. So if we are looking for this guy while having this whole amount, and we have this as well, so we'll say the impure, what is our impure? It's 12, which is the whole amount. We minus what? We minus this amount, which is the pure. Which is the pure, it's 17.76. When you punch that in the calculator, it will give you 0.24 grams. So that's the mass of the impurity. It's a mass of this part. It's 24 grams. Let's proceed to the next question. The next question here, it's 5.4. It says, how will the rate of experiment 2 compare with that of experiment 1? Choose higher, lower, or equal to. Let's look at, we're comparing experiment 1 and experiment 2 to experiment 1. Let's look at the difference between experiment 1 and experiment 2. In experiment 1, we're given the impure sample, which is we're given the entire. So that was used. We used the entire, the purity, the pure, and the impurity. So in experiment 2, we are only given the 12 gram of this. So initially in experiment 1, it was 12 gram of this. Now it's 12 gram of this. Now, so this means that this is going to react. This 12 gram in experiment 2 is going to react this in 12 gram. So experiment 2 will be higher than experiment 1. The rate will be higher. So the answer in 5.4, in 5.4, the rate is what? Is higher than. So surely in 5.5, it says use collision theory to explain 5.4. So it's very important. The mass of what reacted, the mass of what reacted in in experiment 1 is smaller than in experiment 2. Let me repeat it again. So it's 12 gram of the impure sample. So the 12 gram is the entire that consists of pure and impurity. But here, it's the 12 gram of the pure. So this pure, which is it's more now. It was lesser in experiment 1 and now it's more. So if it's more, how are you going to put this? So you will say, when you answer according to collision theory, more magnesium carbonate particles. There's more because there's more mass. More magnesium carbonate particles with correct what? Orientation. The correct orientation, or more particles exposed. You can say more particles what? Exposed, right? Or with more particles with greater surface area. So that's the first thing. Secondly, you have to talk about the effective collision. If there are more particles, that means there will be more effective collision. More effective collision per unit time. More particles, more effective collision, right? How many marks is that? It's 2 marks. That's okay. That's enough. We're done with that question.